So now we're going to go through and see how they're made. So I'm going to show you how this emotion detector, so on aicamp.org, we have a lot of student products, such as an emotion detector here. AI detects emotions. Happy, neutral, sad, surprised, right? So this is Michael here, one of the founders of AICAP. And you can see how it's like, you know, poker face to happy. It's an emotion detector. So how does this emotion detector work? An AI that recognizes your emotion. So we talked about this, right? A little review on how supervised machine learning works. So we give our machine a bunch of labeled data, labels like what are cats, what are not cats, and we ask the machine to do calculations that we talked about, forward calculations for the neurons, make predictions, you know. Sometimes the machine makes mistakes throughout, you know, as it's being trained, and we use back propagation to adjust and make changes to improve our neurons and our overall model. Then we will supply cats and non-cat images in our testing, and then we see how we do. And you know, like if we correctly predict cats and not cats, right? So how many of you guys understand this? Do you guys understand this again? You're seeing some nods. Okay, great. So to do this, how do we know, like, okay, like we have to train happy, right? Happy, neutral, sad, surprised. So how do we know what these are? So we need to collect data, a lot of data. So I want to learn the emotion happy, okay? I want to be able to take a photo of someone and be able to recognize the happy, like that somebody's happy. And this project is helpful, especially for people with autism and others who may not know how to read emotions, or people in general who struggle with reading emotions or telling what emotions are, or maybe you want to be able to tell if someone, you know. So I want to ask you guys, is this okay? I'm trying to learn happy faces. So I looked up happy face. Is this okay? Can I use this to learn about what a happy face is? Okay, so why do you guys think that this is good? Does anybody, okay, Jaxie, do you want to talk more? Okay, but the idea is that you
Can I
see,
say something?
sorry?
Can I explain why I don't think it'll work for an AI?
Mm-hmm. Yes.
Okay, so I don't think that out of what you found on Google, it won't work because if you're trying to train an AI to find, I can't think of the word.
You're going in the right direction.
You're trying to teach an AI to
Okay, sorry, Jax, you think you're breaking up a bit. Okay, but I think Jax, you're in the right direction. So does this look like a human? Is this how we look when we smile, guys? You guys are really good, those of you who guessed. Sorry? So the idea is that if I want to recognize happy and faces, right? Like we have lips, we've got teeth, you know, we've got like, this is a human face, right? With eyebrows, eyes, nose, lips, mouth, right? For the most part, right? You know, most of us look like this. The AI, yes, the AI needs, but it's really good. Guys. Like I was asking to see, you know, now that you, so now this is great that we have different opinions, because the AI needs to read human expressions and not a cartoon. So guys, in programming, what you guys will learn is that literally a program will do exactly what you tell it to do. Exactly. So yesterday was the funniest thing. My brother forgot to turn on the dishwasher. And then I was emptying the dishwasher at home, and I was like, I told my mom, "Hey, mom, like are all these like dishes, like are they clean?" And she thought my brother did it, and he was in the other room, and she's like, "Yeah, yeah, you know, your bro did. He turned it on, right? It's clean." And then I'm like, "Is that dishwasher? Our dishwasher's like almost 30 years. It's touch wood, it's lasted a while." And she's like, "The dishwasher, it's like it's doing its job." So no, she's like the dishwasher, and I was thinking, man, maybe the dishwasher is like falling apart now, and I was really concerned. And then later on, he comes out, and we were slightly annoyed with him. We'd like it's like we had slightly emptied like almost half the dishwasher, and we put all the cups and mugs and everything away. Then he comes out. My mom asked him again, like, and she starts looking puzzled. Like even the spoons are looking pretty messy and stuff. And then he's like, "Oh, I forgot about it. I'm sorry." And then we were like, and I was like, "See, mom, I told you the dishwasher like is probably doing its dishwasher probably was gonna do the job. It's just that he didn't turn it on, right?" So it's the same idea. Like a dishwasher is gonna do its job. If it doesn't, it's probably the fault of a human being in a way, right? So similarly, if we're training a machine, the machine doesn't the dishwasher like doesn't think for itself. The machines or the programs don't think for themselves necessarily. The idea is that if you give a bunch of images of happiness like this with a round face and eyes that are like wide like this, it's going to only learn that this is what a happy face looks like. It will see a human being, and it's not going to know that because our eyes do not look like cartoons. Our eyes don't look like this. Do you see that? It's not going to, it does not match a human face. You see, this is not how we look. So when we supply these images, it's just not going to know like what to do with it. So they're only going to do what we tell it to do. So if you write a program and it doesn't like in programming and it doesn't do what you want it to do, chances are it might be your fault because the program will do exactly what you tell it to do. It won't be able to do anything else. So the idea is that's why we give lots of data, lots of expressions so that hopefully it can try to learn as many patterns as possible. It's like when you're taking your SATs or ACTs, you want to take as many practice exams, get your hands on as many problems as you can get so that you can see all sorts of things, be exposed to as many things as possible. And then you can figure out, like if you have a rule down for how to solve fractions or problems with proportions and the SATs or ACTs, if you see more problems that are at different types, you might figure out, okay, well, maybe I need to adjust something, like this rule that I learned for these couple of problems, I might need to generalize it or something. So it's that idea. So if you want to learn happy faces for humans, you should give happy faces for humans. This would be really good for an emoji detector. So we should change this to happy face for humans. Now this looks more like happy faces. So we need to go through. And then what we have to do next is we have to actually do the following. We will go through and we need to, oh wait, let me actually have this. Like we'll have to go through and actually identify the happy face. And we have to train, we'll make these images black and white. And then we need to train it to recognize. We give these set of pixels and we have to give thousands of it because what it will ultimately start recognizing is a common pattern. Neurons will light up probably that recognize the smiles. You guys remember the neural network, what they will recognize? They're going to be trained to recognize this, essentially. They're going to be trained to recognize this part being part of a smile from the pixels. It's like how we recognize digit S, digit 7. At some point, they pick up on the patterns. But that's why for deep learning, I complained is that you do need to give a lot of data. Like I'm talking at least 1,000 for happy people, at least 1,000 images. So do you guys see that? So do you guys see anything wrong with this, with these, any of these photos right now? If I would like, there's some technology, like something that is called download. I can download all the images on this page if I wanted to. Like I can download all the images, but do you guys see any problem with any of these images here? There's branding in the front. Yes, thank you, Sarah. Yeah, there's branding. There are these like swirls here. Brands, swirls. There's also this cartoon here. And I'll have my favorite example part here. Like, does this guy look happy to you? No. And this is not a person either. We don't look like this. It's so for this thing, you need to exactly show it what happy people look like. This is not a happy person. It's not going to pick up in between. So what you have to do for these things is when you download it, you also have to filter. So even if you write the most explicit thing, happy face human, you still need to go through and edit, because what happens is that there are these watermarks. What the neural network could end up learning is that maybe these swirls or this swirl makes somebody happy. And that's not true, right? Remember, it does not have eyes. It's just a machine. And if we take a course on the immune system, which I did in the spring, which is also a great reason why I went to Madison, I can take all these science courses as well. So I took an immunology course, and you learn how our immune system and our body can help fight off as many like pathogens, like viruses, bacteria, without any eyes. How can it recognize stuff, right? So similarly, these things don't have eyes, and they need to recognize like what's a happy face. So they're going to look for patterns. You need to make sure that you get rid of watermarks and patterns and make these all black and white, because it's not going to know what to look at. It might pick up on watermarks because these are all pixels. Remember, this machine is just a bunch of math behind the scenes. It's not a real human. That's why it's artificially intelligent, because we can almost make it like a human in a way, right? Like, but it's not. It's just a bunch of math picking up on patterns. To learn the digit S, it needs to figure out where those pixels tend to be. And it's not just 5 or 6 images that it figures this out, but it does need at least 1,000 images to get some accuracy. You need to give a lot of images to make it. But the idea is you put all this work up front into making it. And that's what we do in our core classes if you join us. We work on these projects. Yes, you do need to collect a lot of data, but in the end, it's going to be so good. It could be really helpful. Like for the AI predicting proteins, yes, the work that scientists did before by finding the 3D structure of proteins, it was all useful because we ended up putting in some of that data, the unknown proteins, to figure out the structures of other proteins now. But even still, like this Homer, you'll see that even as you download it, so there are multiple ways to get images. Sometimes if you're looking at chest x-ray scans, you need them from hospitals, you need special permissions, you need to be like affiliated with hospitals or universities to get access to that data. Or another thing you can do is maybe you can just um, you can ask people to pose as well. You can take photos. Like if you're trying for motion detector, go on Facebook, take your friends' photos with their permission, take your photos, go through family albums, take photos and then label them, right? You can take photos from happy faces from all over the place, right? And or you can also download them directly from here. You can download all images through these plugins. Or what you can also do is you can just write code. Does anybody know what language this is?
Python.
Yes, exactly. This is Python. So you can also write downloader code, like these are functions to download all the images. So that there are multiple ways. At the end of the day, you need to get a lot of data. And not just that, you need to also label the data. You need to go in and label the data. So you need to basically label the data. So you see that we have for emotion detector, happy, neutral, sad, surprised. You need to label it happy, sad, angry is also another category, and surprised. You need to go in and label that. That's why it's supervised, because for each of the 1,000 images, you need to go in and actually label them. Do you guys see that? It's a lot of work. Yeah, so please do not assume that you know what a job does in a way, because this part, like what if you might say, oh, it's super easy to collect data, but what if you could enjoy this part, or you could be really annoyed with it. Part of it will require maybe you to learn some Photoshop or some technologies to get rid of these watermarks, right? Maybe you don't like it, or maybe you do. Does anybody know how much of a data scientist job actually involves? This is called data cleaning, data acquisition, data pre-processing. Do you guys know how much of a person's job this involves? A data scientist job, what percent? Yeah, 70% is a really, really good guess. Like 80% of a data scientist job could easily be getting the data, cleaning the data, organizing the data. It's like all data organization, and not just for images, it can be any type of data. as well. You have to organize it, clean it, parse it. You could be downloading data from Twitter, for instance, on tweets to see are tweets related to the prevalence of COVID or something, or tweets related to this thing, right? Tweets regarding the election, tweets regarding the temperatures, tweets regarding anything, tweets regarding like Tesla stock or Ford stock or anything, or GameStop, which shot up, in January and Feb. You could be looking at tweets or anything. You have to parse through it, organize it as well. Tweets about the vaccine on Twitter. So you need to organize the data, and 80% is organizing it. The other 20% is the superstar figuring out how to train the model and test it and do all those things. But can you handle the 80% that could be mundane, could be boring potentially? So there are these steps here in this pipeline here, and each of these steps requires like a team effort in a way. So, and every single step in a company is like a team. So 80% of the time, data scientists spend, cleaning the data, labeling it, seeing if it looks good. And 20% they will spend in training the model, evaluating, visualizing results. And what if the model isn't working? We set things up, train the model, evaluate it. But then we deploy it so that others can use our model and it isn't just sitting around. So a key part is you need to determine what we will build. Then you need to collect data, then clean and label the data, train the model, evaluate and visualize the results, deploy the model to serve the customers, continue to monitor the performance. So it takes a team to make good AI products. So yesterday I asked you guys what a product manager does, right? So what a product manager is here. Who wants to read this out? Aaron, do you want to read? Does anybody want? Okay. Sarah, do you want to read this?
Sure.
Okay.
Product managers. I think you have
Oh.
squares all over. Oh, thank you. Deep understanding of a market and customers. User interviews, MVPs, product roadmaps. Talk to people, solve a pain point, determine the MVP, write it up. Communication and writing, strategizing. Serve as the bridge between your customer and your team. Manage team's deliverables. Love tech, but do not want to code all day? This is for you.
Awesome, great. So this could be super important, so that's the first step. So, all these products that we have on AI Camp, right? We have even more products being unleashed each time, which is really cool, rap lyrics, sign language, digits, tumors, emotions, find your next book, ghostwriter, languages, leaf disease, native, song, all these types of things that we can work on here. The idea is that all these ideas come from a product manager. So if your dad or your mom or your guardian's a product manager, then the product manager needs to talk to so many people and come up with a solution. They don't need the engineering or design team, but they need to set a backlog for people to execute, So if you love technology, but you may not like coding necessarily, then this can be for you. So let's say you come to AI Camp, for our core classes, or, you do some programming, or you realize somehow that maybe you just don't like coding. It's not for you. And you're like, oh man, that means I can't be in the tech world, right? Wrong. You can totally be in it. Maybe you can be connected to tech by coming up with the ideas. Maybe you're a really good ideas person. You can find ideas for maybe things that Apple should improve, or on the user interface or other things. Or you can come up with new companies or new ideas for apps. Then you don't have to build it, right? So you're more on the business side. The downside could potentially be that you don't build the things yourself. Maybe taking some programming can help you figure out what there is there, and and what can be done. So it could be helpful to know some programming, but it can be very competitive to get this job. And you might need to talk about your past experiences a lot, but maybe you might really enjoy this. So if you don't try things or collect data, how will you know if you can try this out or major in this or not? So this is what product managers do. They're the actual people who tries to understand the pain point for customers, what kinds of apps will be useful, and then they try to organize the team around it. You know, they conduct studies, maybe they're coming up with, oh, okay, this is what people don't like about the phone, this is what we can do, or this is oh, let's come up with a fun app to do this. You could be an ideas person, maybe you may not be good at coding, but you can still be connected to tech. You know, you can be working with designers and engineers. Then we have data engineers. So if we can have, Kana, do you want to read this?
Yeah, sure. The entire page.
Yes, please.
Okay. Data engineer and data scientists. Engineering skills such as Python and pandas, both you will learn. Build data systems and manipulate data. Establish a data pipeline. Manage a data warehouse. Write Python program. Issue SQL queries. Programming, statistics, and a lot of patience. Fundamental skills in programming, statistics, and data manipulation. Love building data stuff? This is for you.
That's awesome. So data engineers and data scientists are the ones who actually build systems for data flow from one location to another. They like building things. Data engineering is great. Well, the downside is that it could be very mundane, and you know, you don't have to reinvent the wheel, and things can get intense and a bit boring potentially, but it can also be exciting. But 80% of the job is data cleaning. So if you love building things and constantly learning, you could enjoy this. If you love building data stuff, and this is for you. So the determining what we will build, collecting the data, like, you know, looking up happy faces for humans, cleaning and labeling the data, that's sort of like what a data scientist typically does. Then training the model as well is something that they do. So now let's talk about evaluating and visualizing the results.